Alright, welcome to the last video of this unit, which is on a subject called titration. Alright, so titration is a lab procedure that we do. Now, to define titration, the idea is that we're trying to determine the concentration or the identity of something that we don't know. That unknown substance is called an analyte because it's what we are analyzing. The way we determine that information is that we react it with a substance that we do know the exact concentration or amount of. That is called the titrant. All right, so what we're going to do is we're going to very slowly add titrant into our analyte solution, causing it to react. And we're going to stop that reaction once the reaction is completed. When the reaction is completed stoichiometrically, that's a point called equivalence. All right, so once we reach equivalence, we're going to stop. Now, the reason why we know titrants so well is because usually titrants have been standardized, which means we've calculated their concentration to a very high degree of accuracy. All right, the way that you do this and the way that you're going to do this later this year when you make your sodium hydroxide standard is you're going to make a sodium hydroxide standard and then you're going to react it with something called a primary standard. In our case, it's going to be a solid acid called potassium acid phthalate, or KHP. Since it's a solid, you can weigh it out exactly, and when you weigh it out, you know exactly how many moles you have, right? So you know how many moles of acid there are. You add the base until it finishes reacting, and based on that information, you can figure out the concentration of the base. All right, so it's a very straightforward process to do. It also tends to be a very slow process to do because you typically have to add in like one drop at a time. Now, this may bring us to the question of, well, reacting it until we reach equivalence or when the stoichiometry of the reaction is complete is great, but how do we know when we get there? Right, especially if most things are clear solutions. We're not going to have any clue. The way that we would know that, there are two common ways. The most common one is to use what's called an indicator. An indicator is a solution that will change color very close to the equivalence point of the reaction. Right? So, for example, if we're talking an acid-base reaction, we're using phenolphthalein as our indicator. In acidic solution, phenolphthalein is clear. Once the pH rises above 8, which is generally one drop after equivalence, it will change from clear to looking kind of like a pink highlighter. Right, so one drop difference gets a very stark color change. So at that point, we know our reaction is done. A lot of redox compounds actually have their own self-indicator. For example, permanganate. The permanganate ion is purple. But when you undergo the redox reaction to turn it into Mn2+, that purple color will go away. It will become clear for a second, and then it will start turning a very light brownish color. Right, so that's the most common way of figuring out when you've reached equivalence, is just using an indicator. Now, if you want something that's a little bit more precise, then what you do is you use a probe. Right, so if we're doing an acid-base reaction, and we will do this later this year, we're going to figure out equivalence by graphing the pH of the solution as a function of how much titrant we've added in. Now, when the concavity of the curve will change, so when the second derivative equals 0, not second derivative, when the second derivative switches from positive to negative, and the first derivative is 0, we are going to be done. Right, so that's how we'll know when it's finished, is we'll just graph it and from the graph be able to tell it that way. But for right now, we're going to start off working with indicators. Now, setting it up is actually really straightforward. This right here is the titration, I'm assuming, of hydrochloric acid using sodium hydroxide. Right, first thing you want to do for titration, and you may want to pay attention to this because we are going to be doing this as a lab this quarter, is first thing you want to do, the burette. The burette is this piece of glass right here, right? So this glass tube is our burette. A burette is very high precision. The idea is that you're measuring how much liquid you've added. That's why it's backwards. That's why the 50's at the bottom and the 0's at the top. By turning this little knob right here, you can very slowly add solution in. But the first step we want to do is we want to clean out the burette. So we're going to start by rinsing it out with a bunch of distilled water a few times. Then we're going to rinse it with our titrant solution. After it's cleaned, we're going to fill the burette, and we're going to measure the initial volume in the burette. Then we're going to prepare our analyte solution. That means we're going to take a known amount of the analyte, add it to a flask, dilute it, and then add the indicator. Now, things to keep in mind. It doesn't matter exactly how much analyte you add as long as you measure it. Right? So if a procedure calls for like 5 milliliters, it's okay if you add 6. Just make sure that you've measured and you know you put 6 in. It also doesn't matter in the slightest how much water you add. Right? Water does not change the number of moles in the solution. That was determined by the amount of analyte you put in. So choose enough water to get a good visual comparison that the reaction is done. The indicator solution, usually you add 1 or 2 drops. It doesn't take very much. Then what you do is you very slowly add the titrant in. You do it 1 drop at a time, and you swirl between each drop. You do that until the indicator changes color, and that color change is permanent. Because what will happen, especially with this phenolphthalein one right down here, is as you get close to the equivalence point, it will turn pink. But then as you swirl the beaker a little bit, that pink color will dissipate. Then you add another drop, you swirl it, it takes longer for the pink color to dissipate, and eventually you'll get to a point where you swirl it for like 15 or 20 seconds, and it just stays a very pale pink color. That means you're done. Right? So once you've gotten to that point, that's your equivalence point. You then measure the final volume of the burette, and from the volume change of the burette and the amount of analyte you put in the mixture in the first place, you can figure out what the concentration is of your unknown solution. Right, so this is performing a titration. It's a really easy procedure to do. Like I said, it's very time consuming, and it's something where you have to be careful to be very precise with your measurements. All right, so if you have any questions on how to perform a titration, make sure you bring them into class. Otherwise, that is the end of Unit 4.